Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing process, and in this presentation I will be talking about the two special casting processes. These are investment casting process and permanent mold casting process. So, nature wise these two processes are different. This is expandable, means expandable mold casting, and this is permanent mold casting. Means here after casting, after producing one casting, the mold has to be broken and then the new mold is to be prepared, but in case of the permanent mold casting, the same mold will be used repeatedly for production of the casting. So, the second one, that permanent mold casting process is good for the very high volume production purpose, while for the limited volume productions the investment casting is good. So, we will be going through the principle of the investment casting process. Investment casting process. So, in this casting process, first of all we need one metal mold of the casting shape, the means the cavity having the shape corresponding to the casting which is to be produced. So, say this is the mold of the metal. So, in this metal mold what we do, we pouring of the liquid wax. So, the liquid wax is poured into the metal mold so that it takes the shape of the mold. On the solidification of the wax, we get the basically casting of the wax, means the cast product is wax. Now, this wax is used as pattern for producing the mold further. So, this pattern of the wax, say which we have got in this shape, this is the wax pattern. Now, this wax pattern is now dipped, wax pattern is dipped into slurry. Slurry of what? Ceramic particles and sodium silicate. So, this slurry, the wax will be dipped into this slurry. So, slurry will be now coated over the slurry will get applied over the surface of the wax pattern. So, this is slurry which has been applied. Over this slurry now we basically sprinkle the either silica or zircon sand particles. So, they get stick to the stick with the slurry. So, what we do basically this process is called stuccoing, stuccoing, wherein the silica or the zircon sand particles are applied over the slurry which is sticking with the wax pattern. So, when this process is called stuccoing, so these sand particles now will get applied with the slurry attached with the wax pattern and then it is dried. So, this process of stuccoing is done repeatedly, means one layer of the silica and zircon sand has been applied, then again it will be dipped into the slurry and then it will be taken out and the zircon and silica sand will be applied again, that stuccoing will be done repeatedly. So, this is done this process is basically repeated until we get the layer of the silica sand of the silica grains over the wax pattern of the sufficient thickness. So, when this thickness is in the range of 6 to 15 mm thickness. So, thickness of the cell will be governing the strength of the basically this cover or the shell which is being formed. So, as per the size of casting, the temperature of pouring of the molten metal, temperature of pouring of molten metal and the shape of the casting will govern the thickness which is to be used. Once the sufficient thickness of this silica grains over the wax pattern by stuccoing process has been applied, then the wax pattern is removed. So, once when we have applied this silica or zircon grains of sufficient thickness, then this process is stopped. There is one more thing. Once the sufficient size of this one has been applied, then we need to take out the wax pattern. But when stuccoing is done repeatedly, what we do initially over the wax pattern, fine size the silica or zircon sand grains are applied and then gradually increasing grain sizes are applied. So, initially we apply the fine, stuccoing is done using the finer silica or zircon sand, then coarse grains are applied. So, this is how it is repeated all around the wax pattern. So, initially fine and then coarse ones. Once if this has been achieved through the desired thickness, then wax pattern needs to be taken out. So, for removing the wax pattern, basically two methods are used. One is heating of the entire system, wherein this coated or the shell which has been formed and the pattern itself. So, heating will be leading to the heating will cause the melting of the wax, and then additionally the hot vapors of trichloroethane ethylene is applied, so that whatever residual wax is left, all that is removed. So, once the wax pattern has been removed, now it will be left with the shell of this grains, wherein we have fine grains in the inner surface and the coarse ones on the outer surface. So, like this one shell is formed. Now, this shell will be having all fine details of the pattern of the wax which was removed. So, when now this shell is now will be filled in with the liquid molten metal of casting. So, whatever molten metal is to be poured, that will be poured into this cell, so that the casting of the desired size and shape can be achieved. So, this is how what is there in the investment casting. Basically, the fine shell or the mold is prepared, which will be providing the finer details of the wax pattern, and these can be produced easily with the help of the investment casting process. So, shell is like this. So, this cell which has been produced is basically heated, or what we can say, it is preheated. This preheating can be done in the range of 100 to 1000 degrees centigrade before pouring the molten metal. So, this preheating basically improves the fluidity and the filling of the fine details. So, because of these two features, like the preheating as well as the finer smoother surface of this cell which has been prepared, helps to produce very good surface finish as well as close control over the dimensions. So, these are the two features which are realized through this process. Now, application wise, this process has been traditionally used by the jewelers for making the jewelries, as well as for making the ornaments, statues, and also the surgical equipments. But nowadays, this process is used for making the blades, vanes for the gas turbines, impellers for the turbo charger. So, wherever complex geometries with the fine details need to be produced, their investment casting process is preferred. Advantage of this process is that the very close control over the dimensions is achieved, surface finish is good, and very fine details can be achieved, and even the surface finish and the dimensions are so good that even no machining in the components may be needed, and they can be put in directly into use. So, the difficult to machine metals like mnemonics are can be produced using this process, because if the metals are difficult to handle by the machining, then they can be produced. Such kind of metals can be processed by the casting process to make the product, so that they can be used directly without need of the machining. The limitation wise, the process is limited by the size up to say 5 kg size components. And another issue is the expensive nature. The process is expensive. So, for making the products which cannot otherwise be realized through the other casting process can be produced using this process, otherwise this process is expensive, because it is completed in number of the steps. First of all, we have to make the metallic mold, then metallic mold will be used for preparing the wax pattern, then wax pattern will be used for preparing the ceramic shell, and then ceramic shell will be used as a mold for preparing the casting. So, since the number of processes steps are involved, the process is very labor extensive, that is why it is not that economical. Coming to the permanent mold casting process, as name it appears, it uses the mold which remains there, means it uses basically metallic molds. So, metallic molds, mostly these are of the cast irons which are of the fine grain, but it can also be like alloy cast irons or alloy steels can also be used for preparing the mold. Mold, basically these are also called die. In case of the permanent mold casting, like say the mold made of the metal like this, the same one can be used repeatedly for producing the number of the components, but for producing the internal features, mostly these use the collapsible cores. Like say this is the core for producing the internal feature in the casting. So, if the core is located, so the sand cores, or these are also called collapsible cores, are used. So, they can be easily taken off, otherwise it is difficult to make the metallic cores. Metallic cores makes this process complex and difficult, especially the withdrawing of the core. Another one material which is also used for making the permanent mold is the graphite. Graphite mold, mostly the graphite mold is used for the non-ferrous metals like aluminum and the magnesium alloy castings. Like higher the temperature of the molten metal which is to be used, lower will be the life of the mold, because mold has to handle the heat and the temperature and the metallostatic pressure. So, depending upon the temperature, or you can say pouring temperature and the size of the casting, the suitable metal is selected. Since these molds will be used repeatedly again and again, so depending upon the frequency of use of the mold, size of the casting and the pouring temperature, suitable metal is selected, so that it can withstand basically the thermal and mechanical loads related with the permanent mold casting process. So, the selection becomes crucial. If the selection is improper, like the cast irons and the copper alloy castings, they are of the high temperature like 1100 1150 degrees centigrade, the molten metal is to be poured into the mold. So, and if that is to be done repeatedly, then it will be adversely affecting the life of the mold and its performance. So, the metal for the permanent mold should be selected properly, considering the size, pouring temperature and the frequency of the use of the mold for the casting purpose. We know that these permanent molds are, since these are made of the metals. So, when the metal in molten state is poured into the mold, it will have tendency to get stick with. So, this is called, on the solidification, the molten metal, on the solidification, metal of the casting will have tendency to get stick with the mold wall. This is called shouldering of the metal of the casting with the mold wall. So, this will make the withdrawal of the casting difficult. So, this is one thing, shouldering needs to be reduced. And another thing, the metallic mold when poured with the molten metal, it suddenly experiences lot of heat and high temperature of the molten metal. So, it will have to deal with the thermal shock related possibility. So, thermal shock tendency is to be reduced and the shouldering tendency of the metal of the casting with the mold wall is to be reduced, and for this purpose the mold wall is basically coated with. So, mold wall is coated with the suitable refractory materials. So, the refractory material is coated up to the 0.8 mm thickness. This can be either applied with the help of the spray or it can be applied with the help of the brush. And for this purpose, sodium silicate kaolin plus talc is used. So, mixture of these three is used for applying on the internal surface of the mold, of the permanent mold, so that it will reduce the thermal shock tendency as well as it will reduce the soldering tendency of the metal of the casting with the mold wall. Now, we will talk about the advantages and the applications. So, the applications of the permanent mold casting process includes like production of the pistons, cylinder head and other parts of the transmission system of the automobiles, gear blanks and connecting rods, wheels, alloy wheels, all these are commonly made with the help of the permanent mold casting. As far as the advantage is concerned, since the permanent mold are made of the metals. So, the metallic mold they offer good thermal conductivity and high rate of the heat extraction from the molten metal. So, the cooling rate experienced by the molten metal is much higher than that is experienced in case of the shell molding or investment casting or in the sand mold casting process. So, high cooling rate reduces the solidification time and increases the and also reduce the solidification time, and under the high cooling rates this lead to the fine grain structure of the casting. So, the grain structure which is produced by the permanent mold casting processes for the same metal is much finer as compared to those which are produced by the sand mold casting process or the shell molding or investment casting process. So, because of the fine grain structure of castings, it results in the better mechanical properties of the permanent mold casting process. So, this is one very good advantage, and like other processes the surface finish is good, and control over the dimensions is also good, and the process is justified for the means it is economical for large volume production. The limitation wise the process is good for the simple shapes, as well as it is also limited by the size of the mold. So, not good for the large size casting. So, limitations is of the size as well as the shape. Shape has to be simple and the size has to be limited by the size of the mold which can be made. So, not very large size castings can be prepared by the permanent mold casting process. So, now I will summarize this presentation. In this presentation I have talked about the investment casting process and the permanent mold casting process. Investment casting process is used for making the products of having the finer details and which can not be easily machined. Thank you for your attention.